Hello everyone, welcome back to lecture 6 on a course microcontroller. So in the last lectures we studied about the internal components of 8051 and a few addressing modes of 8051. But today's class we are going to discuss about the instruction sets in 8051. So addressing modes are very common for all the types of processor, that is addressing mode sets are common for processor, microcontroller and all, but the instruction sets is different for a different microcontroller. It may varies from family to family. So today's class we are going to discuss about the instruction sets of 8051 microcontroller. So before go for 8051 instruction set, we need to know what is an instruction set. So in order to perform any operation, or in order to perform the manipulation of binary information in any processor, we require some set of commands or operational code, or you may call it as a mnemonics, in order to perform that manipulation. So that manipulation codes or commands, or call it as a instruction set. So in 8051 4 common different instruction sets are there, because here the data transfer instruction set, arithmetic instruction set, logical instruction set, branching instruction set, and boolean operator instruction set. I call it as a 4 instruction set because I included the boolean operator instruction inside the logical instruction sets. I will tell you the later. So data transfer instruction, so the name itself indicates that instruction sets are mnemonics used to transfer the data in between the memory locations to register or internal memory to an external memory locations. And arithmetic operations are the instruction set or mnemonics used to perform mathematical arithmetic operations like addition, subtraction, multiplication and division. Logical instruction sets are used to perform basic logical operations like OR operation, AND operation, XOR operations. So including that some bit manipulated operations, that is called as a boolean operator related to logical instructions. So those are used to manipulate one bit of information. It is related to special function registers. Branching instruction, the CPU execution control, that is program counter address, will transfer to some other part of the main program or external programs. So that manipulation will be done through the branching instruction sets. So first we'll discuss the data transfer instruction set. So data transfer instruction set, I already told, the data transfer instruction sets or the mnemonics is which involves in fetching the data from one memory location and copy that content or transfer to another location. So that can be done in data transfer instruction set types. So in data transfer instruction set, again it is divided into the internal RAM data transfer instruction, external RAM data transfer instruction, and lookup table type of transfer instruction. So internal RAM data transfer section, that means it involves the data transfer in between the internal RAM. In external, the data transfer in between external to internal or internal to external. In lookup table, this is related to ROM location data transfers. So ROM locations is a vectored address, therefore it will call it as a lookup table, or it will call it as also code memory read transfer instruction set. So internal RAM data transfer instruction, I told that the instruction that moves the byte of a data within the internal RAM. So this is a format of move instruction. So in move instruction, move is an operational mnemonic and destination address and source address. The data will transfer the content from source address to a destination address. So this is a move operation. So different 15 combinations of move instructions you will get. Move mnemonics, because we have 4 different addressing modes, we are representing that move with the 4 different addressing modes. Therefore move address can be 15 combinations you will get. So let us look about the mnemonics of 80, that is move instructions. That is move a comma hash data, that indicates, so this square bracket, it indicates the content of accumulator. So here the 8-bit of the data is copied to the content of accumulator. That means 8-bit of data will transfer or copied to the content of the accumulator register. Similarly, this is immediate addressing mode. That means immediate addressing mode, the direct data will be specified in the instruction. And in register addressing mode, the content of register will copy to the accumulator. That is, this is source address and this is destination address. That means the content will be copied from source address to destination address. So source address is register and destination address is accumulator. Therefore content of register will be transferred to an accumulator. So here is an example, move a comma r7 or r6. The content of r7 register will copy to accumulator. Similarly, move a direct, that is direct means this is direct addressing mode. Here directly we are specifying the memory location address. The memory location, the content of memory location will be transferred to the accumulator. That is directly we are specifying memory location. So this memory location address content will be transferred to accumulator. Similarly, move a comma at r0, it is indirect register addressing mode. Here the data is exist in particular memory location and that address will be stored in register as a pointer register. Therefore memory location content will transfer to an accumulator. Okay, so remaining are only we are exchanging the register, that is a source and destination operand. Here we are exchanging the register, and that is a source and destination positions. That means destination address is mentioned by register ri and source is specified with the accumulator. Here the content will copy, that is accumulator content will copy to the register. Similarly, accumulator content will copy to the memory location and accumulator content will transfer to the same memory location pointed by a register. Okay, and so here the move direct comma direct, that indicates memory location to memory location we are transferring the data or copying the data, and directly 8-bit data copy to the memory location. And here in this instruction, register content, that is memory location indirectly addressed by register will transfer to another memory location specified in the instruction. And another type, that is register, that is 8-bit of data directly transferred to the memory location specified by pointer register. And here the direct address means memory location content is directly transferred to the memory location specified by pointer register ri. In this move and transfer instruction, one thing we need to notice, that is register to register transfer is not possible in 8051. Therefore we can't able to transfer ri to ri. Move ri to ri is not possible. We need to transfer that register content to the accumulator and then transfer that accumulator content to another type of register. Therefore memory to memory transfer is possible, but register to register transfer or copy content is impossible in 8051 microcontroller. So this is about internal data transfer instruction. And external move instructions, that is a data transfer instruction that moves data between internal and external memory locations and indirect addressing mode. And here for this operation we are using instruction MOVX. MOVX indicates external memory transfers or copy. So here MOVX A comma at RI, that indicates the content of RI will be, that is content of memory location pointed by a register will be transferred to the content of accumulator. Similarly DPTR, we know that DPTR used to address 16-bit address. So but 16-bit address has some 8-bit of data in the memory location, external memory location. So that external memory location content will be transferred to the accumulator. And remaining two are reverse, that is source destination and destination. Source and destination operands are address are get exchanged, but operation is same. Accumulator content will transfer to memory location pointed by register. Accumulator content transferred to the external memory location DPTR contents. And this is about internal and external. Next we are going to discuss the ROM locations, data exchange, ROM location data exchange, or copying the content to the ROM. So here it is a combination of, because here we are using both program counter and DPTR to perform as a pointer register, therefore we are using the mnemonics MOVC, which indicates code memory, transfer of code memory. MOVC A comma at DPTR plus at A comma at A plus DPTR. That means the physical address of the content is stored in both the accumulator and DPTR register. That means the ROM locations will be physical address. The ROM location is split up into two address. That address, that is physical address, is sum of the address stored in accumulator and DPTR. If you are adding these two, you will get one address. So in that address is related to the ROM location, so that content will be transferred to the accumulator. We are using MOVC instruction. Similarly for PC also, so PC address, that is internal ROM, some ROM locations will be shared, that is split up into two addresses, one of address stored in accumulator A and of address stored in program counter. By adding these two, you will get some ROM location, internal ROM location, that will be copied to accumulator. That can be performed by using MOVC. Push and pop operation. So push and pop operations is used during interrupt subroutine. So during this, the stack pointer will get incremented and direct content will be transferred, that is memory location content will be transferred to stack pointer. Similarly pop is used for retrieving, that is direct content, that is stack pointer is loaded with the direct memory location. The content of stack pointer will transfer to the memory location and stack pointers get decremented. So this is about ROM transfer. And data exchange programs, some instructions are there in order to swap the information in between two registers. That can be done through exchange instruction. Exchange A comma RN, that indicates the contents of RN and A will get exchanged. In exchange A comma direct, content of A will be exchanged with the direct memory location. And exchange A comma RI at RI, that will exchange the information from content of memory location pointed by register to the accumulator. And exchange D, it will exchange the content of accumulator, that is exchange of lower nipples of the content of memory location. 8-bit memory locations will be transferred to, that is lower byte means 0 to 4 memory location will be transferred to the lower nipples of accumulator. So this is about the move instruction or data transfer instruction. And next we are moving towards the arithmetic instructions. Arithmetic instructions are used to perform some arithmetic calculations. So during arithmetic operations, some program status word will get affected. That program status word indicates the results of accumulator. So here majorly carry flag or auxiliary carry flag and overflow X will get affected. So different types of arithmetic instructions are increment and decrement instruction, addition and subtraction instruction, multiplication and division instructions are there. So let us see the increment and decrement operation. So increment and decrement operation, that is so first we will discuss increment. So this is a format of increment instruction. So INC of the source operand, which register you are going to increment, specify that register. So increment A, accumulator will get added by one location or plus 1, so it will get incremented. If the content of accumulator is 2, if you are using increment of A, after execution of this instruction, the accumulator content will become 3, because 2 plus 1 it is 3. Similarly for increment Ri, content of register is get incremented plus 1, so memory location is added by 1 in this instruction. Similarly, content of memory location pointed by register is incremented by 1, and data point register is incremented by 1 position. So this is about increment instruction. In decrement instruction, the format of decrement instruction DEC of source operand. So here the decrement of accumulator A, that is content of accumulator, is decreased by one stage, or content of A, for example A content is 3. After execution of this instruction, the content will become 2. 3 minus 1 it is 2. So decrement of Ri, register, that is content of register, will decremented by 1, so memory location decremented by 1. Content of Ri is decremented, that is a content of memory location pointed by register is decremented by 1. Similarly for addition and subtraction, we are using two instructions or mnemonics, that is add and subtraction. For add operation, add, add destination operand and source operand, that is content will add between addition between destination operand and source operand. These two will get added and result will be stored itself in destination. So add A comma Rn, that means the content of A and Rn will get added and result will be stored in accumulator. For example, add A comma Rn, A is 2, Rn is 3. The content after execution of this instruction, 2 plus 3, you will get a 5, you will get that result will be stored itself in accumulator. And another instruction, that is add C, ADDC, that means addition with carry. That means after the addition operation, we need to add the carry bit to the accumulator again, and itself accumulator will consist both the addition of accumulator content, register content and carry flag. Similarly for subtraction operation, subtraction operation also uses SUBB instruction, destination operand and source operand. These two will get added and the result will be stored in accumulator. And one thing we need to notice, that is borrow. If the subtraction requires any borrow, that will be get subtracted by accumulator. Therefore subtraction with borrow with the content register A and Ri, that means we need to subtract these two, and if any borrow is there, you need to subtract that one also. If borrow is 0, keep 0 as it is, nothing will happen. And it is related to all type of addressing modes are specified here. And multiplication and divisions. So to perform multiplication and division, the instructions are mul AB, source operand and destination operand. So here the A and B value operands will get multiplied and the result will be stored, that is lower order, because multiplication of two 8-bit number you will get 16-bit result. So that 16-bit result, so lower order byte will be, that is 0 to 7, stored in accumulator. Remaining higher order byte will be stored in B register itself. So here the overflow flag will get affected because some signs will get changed. therefore overflow flag will get affected. Similarly, in division, div instruction, div a comma b, that means the value of a is divided by b, and the resultant upper higher order resultant will be stored in accumulator, lower order byte will be stored in b register, reverse of that multiplication operation. And the accumulator content holds the coefficient, and b content will holds the remainder. And one more important instruction we are studying in 8051 addition operation, that is DAA instruction. It is used to used with add and add carry instruction, because here the in during conversion of binary information to BCD, because BCD we need to able to specify only the 8 values, 9 values. After that 9 you will represent with the alphabets. Therefore during addition operation, so BCD is not equal to decimal, therefore we need to convert that value by using this DAA instruction. So DAA instruction will performs in 8 bit of information. If A0 to A3 is greater than 9, that means during arithmetic operation, if any auxiliary carry will get rise or set, we need to add plus 6 to that resultant. That is first lower 4 bits of result in accumulator. If the carry flag is will set, that means at the 8th bit you will get the carry flag. If carry flag will set, we need to add the 6 to the higher 4 nibbles of accumulator content. So this will be convert your BCD content into a decimals.